Okay, it's day 12, AMI day 13. Today you're going to need the 5.1 mass, weight, and gravity worksheet. It should say at the top right hand, day 13. Need a piece of paper. If you cannot print off the worksheet on that piece of paper, top right hand corner, write your name. Physical Science, AMI day 13. Do not put day 12, put day 13 the top right hand corner. You need a writing utensil, preferably a pencil, and a calculator because there will be some multiplying and dividing. And then what your assignment is for today is to read through the practice example problems where it talks about mass, weight, and gravity. There are 2 examples that we will work together. And if you need extra help, you can go to the physical science book, read pages 112 through 115. And then your assignment today is complete 1 through 4, all of 1 through 4. I know they have like sub numbers below them. You also need to complete those. So we need to think back in our thinking cap back to when we learned about mass, weight, and gravity. We said that an object has mass, and all that mass is like this calculator. The mass that makes this calculator is the matter, the amount of matter in the calculator. That is its mass. Mass does not change from Earth to the moon. It still has the same mass. So for example, the mass of this calculator is, I don't know, let's say somewhere around 5.6 grams. It's probably a little bit more than that. I'm just making an assumption. If I took this calculator and I got in a rocket ship and I blasted off to the moon, it's 5.6 grams on Earth. It's also 5.6 grams on the moon. And we measure mass in either grams or kilograms, which is the SI unit, kilo, which is 1,000th of the gram. And then we've got weight. Weight is what we measure ourselves. So like this morning, I'm on this whole workout kick. I looked at my weight because when I step on that scale, the scale tells me my weight. It doesn't tell me the mass like this calculator in grams. It tells me my weight, which is my mass and my gravity. And so weight is just the measure of the pull of gravity on me between the 2 objects. So between the scale and between my mass, whatever is collected there, that is called my weight. And those are measured in newtons or in pounds. When we talk about mass and weight, remember we even said that that changes depending upon where you live in our world. Here in the United States, we use what is called the American Standard or the English Standard way of measurement, where we actually say we weigh a certain amount, where if you went to Spain, they tell you what their mass is. They do not take into account gravity that's pulling on your object yourself. They're just looking at mass. And then gravity is the force that causes all masses to attract on another, which is the strength of the force, depends on the size and the mass and their distance apart. So when we talk about weight and mass and gravity, we've got this handy dandy little equation that we can use. Remember, the triangle is the 3 ratio that we can look at to remind ourselves how to solve an equation or how to solve a question using or looking for mass, weight, or gravity. And so our main equation is weight equals mass over gravity, where the W is our weight, M is our mass, and this should have been a lowercase m. I don't know why it made it uppercase. Maybe because of my font. And then G is our gravity. And so we can take this 3-point ratio and we can put it into our triangle. And we say that, is it weight on top, mass, and gravity on bottom. So if I wanted to find what weight was, it already tells me from up here, if I put my hand over the W, all I have left on the bottom is mass and gravity. Because this horizontal line tells me to divide, I don't know why I did that sideways, tells me to divide the variables, where the vertical line tells me to multiply the variables. So for weight, if I put my hand over the W, I have mass times gravity. If I want to find mass, I put my hand over the M, and that horizontal line tells me to divide. So I've got weight divided by gravity. And if I wanted to find the equation or answer the question for gravity, I put my hand over the G, and what I have left is weight over my mass. So that is how we manipulate that equation to try to find weight, mass, or gravity, because they all have a relation to one another, and it's through this equation. So our first example tells us to calculate the weight in newtons of a 5.0 kilogram backpack on Earth. And it tells me that gravity equals 9.8 newtons per kilogram. So the first thing I always want to ask myself in any word problem, what am I looking for? What is this asking me to do? And if I read that first part of that sentence, it says, calculate the weight in newtons of, it tells me the mass of the backpack. So I am looking for the weight of the backpack. So I know I'm looking for the weight of the backpack. So then I say, okay, what does the equation, what does the question tell us? If I know I'm looking for the weight of backpack, what do I already have that the question says? So first it gives me my mass. Well, if I'm looking for the backpack, I know that I'm going to use the equation weight equals mass times gravity, because I'm just looking for big W. And so in order to find what W is, I need to know what mass is and what gravity is. And so it tells me that my mass is 5.0 kilograms. So I've got one variable. Now I need to figure out what gravity is. And it tells me that on Earth, my gravity equals 9.8 newtons per kilogram. So now I can solve. I've got everything I need to fulfill the equation weight equals mass times gravity. So now I can just plug in for the variables where mass is 5.0 kilograms times my gravity, which is 9.8 newtons per kilogram. First thing I can do is make sure I look at my units and that they match up. And since they match up, I've got kilograms over here in my mass in my numerator, and I've got kilograms in my denominator, so those two cancel out automatically. So then I'm just going to get my calculator. I'm going to say 5.0 times 9.8, because those parentheses tell me to multiply. So the weight of my backpack is 49 newtons on Earth. Okay, so now let's look at the next part of it. It said, well, the same backpack weighs 8.2 newtons on Earth's moon. What is the strength of gravity on the moon? So I'm going to ask myself, what am I looking to answer? Well, if I have a question mark right here, that's the problem. And it says, what is the strength of gravity on the moon? So that is my first part. It's telling me what to look for. So I'm looking for the strength of gravity on the moon, which means I'm looking for the G. So I'm going to go over here and I'm going to remind myself that it's W in the top, M and G on the bottom. But I want to answer what is G. So to find G, I put my hand over G and I block it out. And I say that G equals weight divided by mass, because this horizontal line is division. So if I know I'm looking for G, I know I've got to find out what the weight is and what the mass is. So what do I know? Well, I know weight because it tells me up that in the top of the problem that my weight is 8.2 newtons. Then what's the next thing I need to know is the mass. Well, it's asking me what is the strength of gravity on the moon with that backpack. And if I go back to the last question, it told me I found the weight to be 49. Oh no, not the weight, sorry. I found the mass, or it told me the mass was 5.0 kilograms. So we're using the same mass because, like I said earlier, your mass does not change depending upon where you are in our universe. My mass is going to be the same 400 and something kilograms on Earth as what it would be if I went to nowhere. So it's going to be the same whether this backpack's on Earth or on the moon. So now I can solve. I just need to plug in G equals my weight, which is 8.2 newtons, all over my mass, which is 5.0 kilograms. And I want my gravity to be newtons per kilogram. So my units are correct. So I'm just going to plug in 8.2 divided by 5.0. And because I have two sig figs, it's just 1.6 newtons per kilogram. Why is it 2? Because 8.2 is 2 figs. 5.0 because of the decimal. The rule says it's 2 figs. So it's 1.6 newtons per kilogram. All right, so let's do number 1 together. Number 1 says a physical science textbook has a mass of 2.2 kilograms. So I know that I'm already given the mass to be 2.2 kilograms. Let's go ahead and let's set up our ratio, weight on top, mass in grams in the bottom 2 corners. First question says, what is its weight on Earth? Well, I'm looking for the weight on Earth. And I know earlier from my example, it said, hold on, let's step back. What's my question? I'm looking for weight. And I can find weight by using the equation, weight equals mass times kilogram. So if I'm looking for weight, what is my mass? 2.2 kilograms. What is the gravity? If we look back at the example, gravity never changes on Earth. It is always going to be 9.8, because it's a constant, newtons per kilogram. So I can just say that weight equals 2.2 kilograms times 9.8 newtons per kilogram. Our units all match up. Kilograms the numerator here, denominator there, and it cancels out. So I just plug in my calculator, 2.2 times 9.8, and I get 21.56. But I have 2 sig figs here, 2 sig figs here. This is 1 digit, 2 digits, so it's 2. 1 whole digit, 1 whole digit, so it's 2. So I just have to put in for my final answer 22 newtons. Why is it 22? Because it was 21.56. That 5 has that 1 round up to 22. All right, second question. It says, what is its weight on Mars? We're talking about it. It is physical science. So first thing we think is, what are we looking for? Well, we still want to know what is weight. So if I'm looking for weight, I know that I need to know what is mass. And my mass never changes. Because it never changes from Earth to Mars, my mass is still 2.2 kilograms. Well, and now my mass, I know what is gravity on Mars, and it tells me that it's 3.7 newtons per kilogram. So now I can just plug in, sorry, that I should not have done that ending. So now I'm just going to plug in my weight, 2.2 kilograms, times my gravity of Mars, 3.7 newtons per kilogram. My kilograms cross out. 2.2 times 3.7 equals 8.14. Got to look at my sig figs. I've got 1, 2 here for a total of 2 sigs. 1, 2 here for a total of 2. So my final answer only needs 2. So I take 8.14, and that 4, because it's not over 5, it just says 8.1 newtons. That's my answer there. That's my answer there. And the last one says, if the textbook weighs 19.6 newtons on Venus, what is the strength of gravity on that planet? So what's it asking us to find? Yeah, we want to find the gravity on Venus. So I know that I'm looking to answer the question for gravity. Oh, sorry, let's make that a question mark. Question for gravity. And so in order to find what gravity's equation is, I put my hand over by my triangle, and what I have left is gravity equals weight over mass. So I need to know those two variables. So I need to know what is the weight, and it tells me that it is 19.6 newtons. Well, now I need to know what is the mass. Well, the mass of the backpack never changed. The amount of matter in that backpack stayed the same as long as nothing was added to it or taken out of it, but it still stayed the same at 2.2 kilograms. So now we're just going to set it up where gravity equals my weight, which is 19.6 newtons, divided by my mass, which is 2.2 kilograms. I'm going to take the 19.6, divide it by the 2.2, and I get 8.909090909. Well, I don't need all those digits because they're not significant. I need to figure out how many are significant. So I've got 1, 2, 3 here. I got 1, 2, and I take the lower of the two numbers. So it's going to be 8.9 newtons per kilogram. Okay, so now I've done number 1 with you of your practice. So that should be easy peasy, 6 points, over and done with. Now you're going to do 2, 3, and 4 on your own. So make sure if you don't have it printed off already, go ahead and get a piece of paper out, or you should already have a paper out and been doing this with me. And you should have no problems, hopefully. If you do have problems, make sure you message me or you send me a message through email, and I'll help you out. Remember, I'm not just here to help you on physical science. I can help you on any other questions that you might have related to science. I really love math, English. Don't ask me much about drama or speech. I'm not very good in those. But other things I can try my best. So hope you guys are having a blessed day. It's Tuesday. Get out in the sun, get you some vitamin D, and have a blessed day. Bye, y'all.